Hello, everyone. You're here today for DEV315 for AI agents and databases, discovery, recommend, and optimize. I'm Rob Koch. We also have Nam here. I'd let her introduce herself. I'm also 25 years of IT consulting. I'm the co-chair for the CNCF Deaf and Hard of Hearing Working Group. And when I'm not doing any work, I love doing AWS CNCF community-based things. I also really enjoy running in the outdoors. I'll pass it over to Nam to introduce herself.
Hello everyone, my name is Namrata Shah. I also go by Nam. I have over 20 years of IT consulting experience working with multiple clients across different domains. By passion, I'm a YouTuber and I run my own YouTube channel where I post a lot of AWS tutorials and labs. So if you're passionate about learning AWS, feel free to follow my journey. The handle to my channel is right there on the screen. And I love sports. So for fun, I basically play badminton and tennis. So with that, let's get the session started. So we want to start with a quote over here. So when databases can discover, recommend, and optimize on their own, they stop being reactive systems and become intelligent partners. I believe all of us have been where we have seen database bugs or issues or challenges in production once we have deployed them. And in most cases, what we have done is we have reacted in a rushed manner to resolve these issues. Our session today focuses on moving away from being reactive to proactive, and basically converting these reactive systems into proactive, intelligent partners that can discover, optimize, and recommend by themselves. And if you ask how, well, that is going to be with the help of AI agents. Let us quickly go through the agenda. First, we are going to discuss the challenge at hand. Then we will discuss our vision to resolve this challenge. It's a common challenge, so most of you should be able to associate with it. We will also discuss why AI agents and how AI agents can help us, what they bring to the table. Post that, we will discuss about a few AWS data services and see how AI agents can help us to transform these reactive systems into proactive, intelligent partners. And of course, we will have demos wherein you will see this. Over here, we have recordings with us, just to ensure that we don't depend on the Wi-Fi. It sometimes tends to go down, so we have a recorded version. And after this demo, hopefully you guys feel confident and empowered to take this knowledge back and convert your reactive systems into proactive, intelligent partners. After that, we will discuss about the benefits of doing something like this, and we will let you go with some call to action. So with that, I will hand it over to Rob to get us started with the challenge.
Great, just to let you know, I forgot to explain that I'm deaf and I use sign language. And so I've got interpreters who are voicing for me over here. So that's who you're hearing. So if you're hearing the voice from somewhere else, it's because they are off screen. So I just wanted to start with that. So before here, we've got the challenge, the database issues, and the performance issues that we have. After those things get diagnosed, the disruption of the workflow tends to happen. Things come up in production. Often they're catching off guard or blindsided in the moment. Maybe they have, something happening during peak business hours where there's a large data load or a big release. And so there's a lot of investment in monitoring tools and metrics that are added to dashboards, being able to see everything for the organization itself. And they can get caught off guard sometimes, right? We slow down, maybe we failed jobs or unpredictable spikes in their business. Also, storage and compute costs can get disrupted, and issues with that. It's not the telemetry, that's the raw data, of course. So that's not the issue. What the issue is mostly the system capturing the data about the data, but there's not an understanding of why. And so having that being, coming up and then scrambling with all of these metrics all over the place, trying to figure out what the issue actually is. So developers typically will struggle with that and have an issue with the prioritization of how to diagnose slow queries maybe, whatever is disrupting the workload, balancing the cost and performance as well. So there's different environments in that regard that are having these issues pop up in different ways. Performance degradation, that does happen. It's easy to drown in tons of information on the dashboards with hundreds of alerts. So the metrics of CPU, I/O, query latency, etc., they don't really explain why the problem is happening. So when we have every alert, it seems urgent, but it's not always actionable, right? So not knowing how to explain what the problem is, not being able to fix it, what the alert looks like, the urgency level, etc. And even an experienced engineer can lose sight of what is particularly impacting the databases. Or the business itself, even. You get alert fatigue, we all know that. A lot of information coming at us all the time, right? People tend to ignore those alerts. The scaling costs and predictability to add other layers of complexity. We have auto-scaling promises, but in practice, where the usage patterns themselves and the transactional workloads rarely follow the predicted workflow. So we try to over-control, and we experience that data fatigue. Growing and aging and optimization, of course, the costs can blow up really fast before the improvements are seen. And the lack of clarity in the feedback loop between performance decisions and the impact of the finances as well leave the team from aligning operations and those choices involved with the business prioritization. They tend to conflict. And so in the end, we end up being reactive, and it doesn't have any equivalency to the business goals. So one of those things that are prevented through observability history and context and intelligent auto-scaling as well, moving control from more controlled requirement of the culture shift. So less focus on the intermedium of every single component, more understanding the system behavior overall, holistically. And that's really what the data keeping your environment under control, consistent, and I will move on now to the vision. So the vision, we've all been there, right? We've had this experience before where the metrics show up, and what do? So there's a lot of different, red notices, and we're chasing down the root cause of any of those things after the fact. So this is a reactive loop based teams live in. So with this, we can get ahead of the problem and see what's coming, and as to what's happening, we fix the problem. Thinking about what's going on with the database on its own and the workload. Over time, we learn that they ramp up, maybe business operations on a Monday morning, let's say, or we have something that is the month-end billing that we want to view, that particular spike. Maybe we have another example, like you start to notice something's off, and it's not every spike being a crisis, right? It's not always a war room situation. With AI, we can let the system separate the noise from the signal and point to exactly where the issue lives. And this is not about getting any other alerts at 3 a.m. on your phones, bothering you. It's about guiding you and to a real actionable recommendation. So we're changing, like maybe the index, or we're reallocating the compute, or the system is learning from what works and then keeps tweaking itself, and it gets better the longer it runs. So the Direction can be focused as an active participant on its own performance. When you bring everything together in the predictive analytics, the optimization algorithms, and the workloads context, you can stop reacting and start engineering. Outages are reduced, costs flatten out, and databases start to feel more intelligent, like an intelligent teammate, rather than a service to maintain. So you might be asking, why AI agents, right? Modern data environments move very fast, and humans can track that, as well as the AI agents becoming essential for the database operations. We have reactive alerts that break down and distribute the cloud-based system where we're measuring the metrics and the logs, and the query data changes constantly. So requiring that consistent interpretation is based on observing and reviewing. AI-powered monitoring can shift to collecting the telemetry to learn from it. AI agents are also model normal behavior and can be adaptive to switch over to various baselines and be able to assume those in real time across CPU, across query performance, across the latency, and continue to learn from that behavior. Things that might have been overlooked in the past that weren't visible, degradations or outages. So context is where we get. This is very helpful. So if we have a measurement, something spikes, the AI systems can explain why it changed. What is the impact of that, and what are we doing next? So when that changes, the raw telemetry can diagnose then and express that. Maybe it's sending out a ticket, maybe it's creating a user story, maybe it's fixing the actual indexing. It can be tuning the configuration. Maybe we need to restructure the query. And the AI agent can also change from something that I think maybe looks off. It's right there, and it will show you what the problem is. Here's the action, here's what you need to do, and you can be proactively intelligent, reduce the noise, and really align to the issues and the matter. To give the database a clear option before the degradation of performance happens. As the database continues to scale, in this day and age, this is something that we need to be adaptive to, this particular driven monitoring, and stop being a nice to have, but being worth the capability for resilience and efficiency. Now I'll pass it over to Nam to talk about the data services with AI agents.
Thank you, Rob. So our next section is AWS data services and AI agents. And as I said earlier, we have shortlisted a few AWS data services that we will discuss, and we'll demo some of them to you as well. For each of these services, we have shortlisted 3 challenges, and these challenges have been shortlisted based on our experience. So since this is level 300, we will give a quick overview or a refresher of the 4 services that we have shortlisted. We assume that most of you guys have worked with these services. The first one that we have is Amazon RDS. Amazon RDS is a managed relational database, and it supports MySQL, Postgres, SQL Server, Oracle, MariaDB. After that, we have Amazon Redshift. Amazon Redshift is a cloud database warehouse, and it is known for its analytical capabilities, as well as it supports massive parallel query processing. After that, we have Amazon Aurora. Amazon Aurora is native to Amazon, and it's also called as a cloud-native database, and it supports MySQL and Postgres. It's compatible with those. It's also known for its high availability, auto-scaling, and replication capabilities. And the last service that we have shortlisted for today is DynamoDB. Now, DynamoDB, of course, is a fully managed serverless NoSQL document DB, and it is known for a single-digit millisecond responses. So this was a quick overview and a refresher of what each of these services are. And with that, it's time to deep dive into each one of them. So the first one that we have is RDS. And the top 3 challenges that we have shortlisted based on our experience are the following. And we will see how AI agents can help us to move away from being reactive to being proactive. Remember, that's the goal, right? So the first challenge that we have shortlisted is query performance. I believe all of us have dealt with this at some point in time after deploying it in production. And why does something like this happen? What is the root cause? First, it could be the query itself. The query is not efficient. And the query plan, of course, because the query is not efficient, is probably not efficient. You have some missing indexes. Your schema design at the grassroots level could be suboptimal. Now, if you ask, how can AI agents help with something like this? AI agents can review your query, can review your query execution plan, can review your indexes. If there are any missing indexes, they can recommend certain indexes. They can, worst case scenario, rewrite the whole query for you, saying that, okay, you know what, forget this query, I'm going to rewrite the whole thing. This is far more performant and better compared to what you have written. And what is the benefit of doing something like this proactively? Of course, you have a much better query, a query that is optimized. If there are any missing indexes, then those indexes will be suggested to you and recommended for you. If there are any schema changes that are needed, then again, the AI agent is going to recommend some of those schema changes to you as well. The next challenge that we have shortlisted is manual instance scaling. Now, while RDS scales really very well horizontally, let's say after deploying, if you want to change the instance, you will have to do that manually, okay? And this sometimes becomes a challenge. So while horizontal scaling is very easy, scaling vertically or changing the instance type can be a challenge. Now, in most cases, you have to just deal with it and figure it out. And when we are saying you want to change the instance size, it is based on the workload that is running on it. Remember, the instance is always relative to the workload that is running on it. Now, how can AI agents help us to determine something like this? AI agents can analyze the CPU utilization on the current instance. They can also analyze the memory utilization, your I/O. They can actually go and look at your workload and your workload pattern that, hey, you're only using 10% or 20% of the resources on this particular instance. And most importantly, by analyzing all this, they can actually help you to right-size the instance. Okay, so the benefit, of course, is saving money over here. Imagine if you have 1 or 2, it's fine, but if you have hundreds of instances which are highly over-provisioned or possibly even under-provisioned, in most cases generally over-provisioned, then you have trouble. And the next challenge that we have shortlisted is storage optimization. Now, as humans, apparently, we love to over-provision things because we are scared that, hey, what if it does not work? I'd rather have it a little bit more. And in that event, we tend to over-provision everything, not only the instance, but even the storage. And from our experience, what we have seen is that a lot of times because of this, there are unused volumes, okay, and the storage that has been provisioned is far larger than is necessary. So let's say you are probably using or growing by 20 gigabytes, just to give an example, per month. And you've probably provisioned something which is 10 terabytes or half a petabyte of storage. Now, AI agents can look and review your metrics, your I/O, your storage utilization patterns, and again, help you to right-size your storage. Now, the biggest benefit, again, over here is price performance optimization. And of course, you have a better performing overall RDS instance. Now, with this, it's time for a demo, and we are going to show manual instance scaling and storage optimization to you. So I'm going to request Rob now to demo this to us.
So this is the moment you've all been waiting for. It is the time now for the demo. And so we can go ahead and switch over to that. What we have here is what I've built in a particular instance, generating the data all day and all night. that it's been up and running for about a week. So generating the data here with the MCP server, the model context protocol, and that here is included in the bridge, and to bridge the gap between the AI interacting with the technical control of CloudWatch, RDS, and different things here. Manually running the MCP server here, you're able to have your app orchestrate and run and make recommendations for storage, optimization, allocation, different type of group names, etc. So not needing necessarily to remember all of the manual API calls, it will give you all of these for you here. So you can see the workflow and the query making modifications and reporting back. Here we've got the Kiro CLI, which is letting the team be proactively analyzing and implementation of the optimization in the cloud database. And then it's using the agent to provide the interaction between that. So there's specific goals. You can track those goals here. And to capture the most accurate picture of the state of the database. We're using Kiro and this driven approach to be able to provide context through the workflow. And don't forget to define the optimization goals so you can have the relevant metrics up front. Here we're showing the needs of the monitoring and connecting CloudWatch MCP, as well as the needs to provide the appropriate requirements, pulling in the information in real time from the performance and the cost and the utilization, etc. By using that integration of the MCP, it will automatically aggregate all of that for you here. So these simple, important metrics with consumption, IOPS, query, latency, all of this will help to optimize the recommendations. When we walk through the integration of the customer's playbook or runbook, we can add those to these metrics here, and you can decide between the context, whether it's intentional, and making specific recommendations based on that. So the transactional logs here, maybe it's resizing the storage, maybe you're enabling auto-scaling, maybe it's based on well-defined business policies and patterns. So now we're looking into this recommendation that's been generated. And so this demo will show you, I wanted to say the emphasis is that the agent is making the decision that your app can be automated and show up with the cost optimization recommendations, and then also providing the reasoning behind it, why it's making that exact recommendation for you. And here, if you dare to try it, you could get this up and running with tasks, maybe making modification of storage size, retention policies or periods. Also, these things are trusted issues that we have with AI agents. And then the rest is up to you. So having a playbook in your organization, that can be integrated here as well, like I mentioned. And so this can make decisions to provide more better and larger context to the situation that's happening. That will intelligently give you information and actions to take. And that's pretty much closing that loop between the detection, the analytics, and the solution remediation, showing that the difference between the AI agentic development and the server, as well as the AWS observability, where you can continuously monitor your price performance and optimization. So this is for the RDS workload. Mm-hmm. And this is great because we all know how we type out the CLI commands. Sometimes we have typos, right, everywhere. And so this can help with that. It lets you generate the CLI commands for you. So they can be complete or integrated with your current API, etc., giving you those less back and forth struggles of like, which flag was I using before, and maybe forgetting that. So this helps a lot. You also have like 72-hour period, it says here. You've got the 2 instances that are running, let's say, for a week. And then the optimizations of, yes, being able to slow the traffic down overnight and weekends, becoming more relevant to the production workload. So here it's making recommendations for sizing. The T3 medium, which is still pretty small in the enterprise workload because we value our AWS billing, right? Of course. So making recommendations for T3 small here now. You can see that the business hours, the off hours, explaining why. It's always the piece of AI is explaining why it's important, which is great. So you can see the recommendations here. Now we'll pass it back to Nam.
Perfect. Hopefully you guys like this and you feel confident. So let's move on to the next service, that is Amazon Redshift, and look at its first challenge. The first challenge that we have shortlisted for Redshift, remember, it's a cloud-based data warehouse, is skewed queries. And skewed queries typically happen because of uneven data or workload distribution across the different nodes of a Redshift cluster. Now, AI agents can look at our query logs, can look at the query, can also look at the load distribution across the different Redshift nodes, and then provide certain or optimize it as well if required, your data redistribution or workload redistribution strategy. An outcome or the benefit of doing something like this would be having an evenly distributed cluster, and of course, your queries will be far more performant and faster. The next challenge that we have shortlisted is inefficient joins. Now, when Redshift runs a lot of queries, remember it can run massive queries parallelly, a lot of times what we have seen is the number of joins in each of these queries are significantly high, and that causes a certain amount of data shuffle or data movement across the nodes. Now, AI agents can again analyze our query plans, can look at the data distribution keys within your Redshift cluster. They can actually even go back and look at your schema and possibly suggest certain denormalization so that you can get rid of some of these joins completely. Benefit of doing something like this, of course, your query is faster, you have lesser number of joins, and you reduce your network I/O. And the third challenge that we have shortlisted for today is suboptimal distribution keys. Now, if you really go to see, all these three are actually linked in a way. Having suboptimal distribution keys essentially is a challenge at a schema level or at an architectural level. That's a root cause, right? It's something that you detect the after effects or the side effects of having suboptimal keys in production. Now, because you have suboptimal keys, you can possibly have skewed queries as well as inefficient joins. Now, our AI agents can actually go and review and look at your schema, can look at your distribution keys, can also recommend certain distribution keys to ensure you don't have skewed queries or inefficient joins, and thereby making your overall Redshift cluster far more performant. So in our next demo, what we are going to do is we are going to show you an agent that is going to review through your Redshift architecture and provide you recommendations. So now let's see that in action. So Rob, over to you.
Maybe. So now we're going to go through the demo of the architecture here. We're using the same tool as the Kiro CLI and walking through how the AI-powered agents can be surviving a few Redshift challenges that we might see here. So I'm building the Redshift cluster, building that out, putting some of the tables there and the data models, putting those in place intentionally to make it not efficient. So we'll see if the AI can pick up the difference here and provide the recommendations appropriately. So what we're seeing in the picture here is the agents will connect to your Redshift cluster at the start of doing what the humans are struggling with to scale consistently or continually and analyze those queries and the nodes to have the most effective reaction time. So slowing down what should be, with the agent, it's looking into the patterns and then detecting the root cause that will appear here. So it's something like, table X is experiencing a row skew because of the current distribution key. And so that's grouping that together, 80% of the data on a single node. And that's not necessarily a flag, but it'll make a recommendation to have a better distribution style that can be shown in what that cardinality, the new version, will look like. So estimating the performance enhancements, and then you can see here that there are no trial and error testing that costs you money that would have in the past. It gets right to the point and pinpoints what's going on. So now we'll fast forward to the future time period where, let's say, we've got weeks of historical data, and you'll notice here the patterns and the end of the month billing, for example, and we're seeing maybe some spikes, maybe Black Friday, that will triple the query volume. End of quarter reporting maybe impacts and making predictions. So using that historically, we'll then forecast the next spike before it actually happens and then make recommendations for right sizing. And maybe you're setting up an auto scaling situation where you don't have to worry about, scrambling to be prepared for that. So that works because the agent adds the context. And it's not just saying CPU's high, right? It's explaining why it's high, what it's going to cost you, and exactly what the action is to do. So moving the needle. The gaps between the raw telemetry and the actionable improvements, where they are most, teams won't waste their time and money trying to figure that out. So we're closing the gap here and taking both the cost savings and then the performance boost that you get out of that comes from running the system efficiently. So leveraging AI to bring you the database operations information. Sometimes the AI agent will give you too much information. So like here, it's built out some Python script or some SQL script for you that we probably don't need, or maybe we can add more context to the prompt. When I'm testing it out here, you generating the recommendations like you're seeing here, fact finding, and you can reuse that Python script maybe that it generated for, let's say, a dashboard. That way it will always be consistently monitoring the database. So now expanding the dialogue with the concrete examples here, showing you the progression of things from detection to optimization and forecasting, and then ties that back to the business impact. And that's the cost and speed of doing business. So now I'll pass it back to Nam again to go into the different data services.
Okay, thank you, Rob. So guys, we've completed 2 of our data services, and now moving on to the third one. The third one is Amazon Aurora, and I believe all of us have worked with this one as well. The first challenge that we have shortlisted for Aurora is replication lag. Now, we generally, from our experience, have seen that replication lag happens when the server has way too many writes compared to the read. And hence, because of that, it kind of generates a replication lag wherein the data, once it's written, is not being replicated across the read replicas. Of course, network latency also plays a role in that as well, and could be under-provisioned read replicas across the different AZs could also be one of the root causes because that causes the replication lag over here. Now, how AI agents can help us? AI agents can monitor our replication metrics. They can actually even predict the replication lag, as in it can actually say that, okay, if your writes go beyond a certain amount, there is a high chance or a possibility that you can potentially face a replication lag. It can also predict this way ahead of time so that you are mentally prepared. And also it can recommend certain read replica tuning as well as certain failover recommendations as well. Benefit of doing something like this proactively, not reactively, remember that, it's always proactive, is of course your chances of having replication lag reduce significantly. If you're having any network latency challenges, you would know them much ahead of time rather than discovering that in production at a much later state. And if you don't have replication lag, that means your writes and reads are in sync. At the end of the day, your read consistency will be far more better. The next challenge is connection stamps. Now, none of us are immune to this one. All of us have been there. Okay, all of us have seen those situations where the server, or the database in this case, has ran out of connections. And why does something like that happen? Something like that happens because there are way too many unused connections. Of course, a lot of times as developers, all of us have been guilty of opening connections and not closing them. What happens as a result of this? Well, the connection pool is overloaded, the server gets depleted in resources, and now when a genuine connection request comes in, that request is going to be rejected. And can AI agents help us detect this? Yes. AI agents can look at your abnormal connections, connections that have been opened, connections that have not been used, connections that have been open for a very long time and not closed. And they can basically also suggest certain connection pooling or throttling strategies as well. An outcome of doing something like this is stabilize performance and reduce risk of having your server down, and especially having a server that is not depleted in resources. The last challenge for Aurora is scaling bottlenecks. Now, this is kind of also connected with replication lag, and it typically happens because, again, when your reads and writes are not in sync. What we have seen is when the number of writes go significantly higher, your read replicas are underutilized. And your AI agents can forecast your workload trends, can forecast your workload patterns, can also recommend certain read replica fine-tuning or auto-balancing strategy so that your reads and writes are in sync. And benefit of doing something like this proactively, of course, you have a well-balanced cluster. The next, we don't have a demo for that, so I'm going to move over to the next one, and that is DynamoDB. For DynamoDB, one of our first top challenges is hot partitions. Now, hot partitions typically happen because of uneven key distribution across the different partitions. And as a result of that, we have one specific partition that is overworked. A hot partition is a partition that is overworked or overutilized. Why? Because that's like sitting in the hot seat, right? It's always under pressure. Now, AI agents can actually go and detect your hot partitions. They can analyze your workload patterns. They can analyze also your data load distribution across the different partitions and even recommend better partitioning or sharding strategies. Outcome of something like this, of course, you have lesser chances of having a hot partition because your data is going to be evenly distributed across different partitions. The next challenge that we have is throttling. Now, throttling typically happens when the server is under a tremendous load. Now, whenever you provision your DynamoDB, you provision your DynamoDB with certain capacity limits. And when those capacity limits are exceeded or are met beyond because of some disproportionate amount of traffic coming your way, that's when your server starts throttling. Now, AI agents can essentially forecast this, that, hey, your capacity limits are, you're almost getting over there, they're up to the limit or they're up to the threshold. They can also basically adjust your capacity limits dynamically. That's another benefit. So it's not just making recommendations. It can also optimize it for you if you want it, of course. You can always have Lumen in the loop over here as well. And as a result of this, we will have fewer incidents. It's not going to eradicate it completely, remember, but fewer incidents wherein we have a server throttling. In this case, it's not a server, but our database throttling, essentially. And in that case, the overall performance of DynamoDB becomes far more stable. And our last challenge is a cost spike. Now, this also happens because of an unpredictable amount of traffic coming away. And as a result of that, the server gets into a burst scaling mode. And suddenly your budget has gone out of the window and you have a cost spike. And this typically happens because of disproportionate amount of traffic. And now you have a cost spike. Now, AI agents, again, can step in over here proactively, look at your workload patterns, suggest certain auto-scaling strategies. In order, depending upon your situation, in order to avoid a cost spike, it can also suggest certain caching strategies wherein you could direct some traffic over there rather than having a cost spike on your DynamoDB server. And as a result of this, you will have an optimized cost, consistent performance, and basically lesser chances or fewer chances of having any of these challenges. So that concludes this particular section. And with that, we will move on to our last section, which is benefits and call to action. So Rob, over to you.
So the AI-driven monitoring here is a major benefit. It enables the proactive monitoring to catch issues earlier and reduce the outcome of improving performance and offloading some of those analytics and shifting those to an automated approach. A DBA productivity will have a huge leap with the overhead, and that cost management will be more intelligent, being able to tweak should be, always continual, right? So making sure that those extra resources are optimized without too much manual effort. So moving from being reactive to being proactive, and the usability of predictability, operations, and things that are smaller, and going back to work, start small, deploy one thing where the AI agent can help you there, one single service maybe, and we'll probably see immediate value. And then you can measure that, and the results will prove it out, and then you can scale that across your AWS database ecosystem. The integration of AI agents will be proven out the best practices, and that you can use, like I said, your organization's runbooks, and that will have a transitional journey impact to the intelligent, proactive recommendations. That will unlock higher efficiency and resiliency.
Okay. So towards the end of our session, we would also want to end with another quote. So while today's databases act as reactive systems and we react typically to resolve these situations, we foresee that in the future, these reactive systems will basically become our proactive, intelligent partners. And today's session focused on that. Hopefully, you guys now feel a little more confident and empowered to go back and apply this to your own reactive systems and figure out ways to kind of make them or transform them, let's say, into proactive, intelligent partners. Now, of course, we only covered 4 services considering the time at hand, but something like this can be extended to other AWS services as well. So with that, thank you very much. We hope that you enjoyed our session. You can connect with Rob and myself on LinkedIn and YouTube. Please complete the session survey on the mobile app, and Rob and myself will be available post the session outside. Because it's a silent session, we cannot take any questions over here, but we are happy to take any questions on the side. So thank you very much for attending.